Welcome back. I've got another question here. There's so much content in this solving exponential equations that have a context or a story surrounding them that, that 6.5 minute that I did for part one, I wanted to see if I could get it a little bit tighter here for this part two and also give you some extra opportunities to see things. These are challenging. Take it a little bit at a time. Keep track of your progress. This is one of the reasons why I like a notes record of what you've been doing is probably a good idea because you're going to see some consistent things over time. Here we go. Lamar harvests a lot of cherry tomatoes in his garden this year. Each day he keeps half and brings the rest into the office to give away. By the time the tomatoes start to get a little mushy, Lamar has less than 1/64th of the original harvest left. How many days after Lamar harvested tomatoes do they start to get a little mushy? He keeps half and brings the rest to the office. And therefore, from the time the tomatoes are picked fresh, the moment where he first picks them, he's got 100% or all of his tomatoes. And then over time, he has half of that, and then half of that, and then half of that. So these are day one, day zero, day one, day two, day three, day four, right? Half of 1/8 is 16th. Okay, that's day four, then day five, and then day six. Filmed before a live studio audience. Thank you so much. So in this case, I guess it looks like after 6 days, he's reached a situation where he's got, only 1/64th of his original, collection of these left. To write an equation or inequality, right? After this point, mush. So you throw them out. To write an inequality for this one, we got to think about what's consistently happening. How do we go from 1 to 1/2? How do you go from 1/2 to 1/4? How do you go from 1/4 to 1/8? This is the structure of a geometric sequence. R equals G sub 0 equals. We need to know both of those numbers in order to be able to write the equation. Well, the way to do R is to take the second number and divide it by the first number. 1/2 divided by 1. That was easy. Let's just prove 1 divided by 1 is easy. Okay. Let's just prove it. Let's do 1/4 divided by 1/2. Get to first period. Okay. So 1/4 divided by 1/2. 1/4 divided by 1/2. Hey Siri, what's 1/4 divided by
1/4 divided by 1/2 is 0.5.
0.5. You could use the decimal or you could use the fraction. Maybe the decimal is going to be a little bit easier, but if you have a weird decimal, then the fraction would be best. So I'm going to use that one. And then I notice right here, the 0, he's got 100% of his tomatoes, or 100% is the same thing as 1 whole. So there we go. Write the equation 1 times 0.5 to the x. There it is. This is the structure of a geometric sequence equation. Technically, for a geometric sequence, we had -1, but because I'm using the 0 value in our list, then it's -0. And what is x minus 0 except it's just x? Type it in. Here goes. Okay. 1 times 0.5 to the x. All right. We want to know when it's 1/64. So there we have 1/64. Oh, it auto-corrected the 0.5 to 1/2 to the x power equals 1/64. See, I'm going to keep track of what I'm writing right here. I'm going to assume it's equal sign because I see after how many days. I didn't like that. I didn't like the after how many days. Maybe it's at least this much time. So therefore, I'm going to go with the symbol that says 1/64. We're guaranteed at least that much, but we're talking about anything after that is also allowed. So I'm going to choose, didn't like it. This symbol, now I'm just guessing. Did not like it. It means that it's less than. The problem tells you that the fraction of cherry tomatoes Lamar has remaining is less than 1/64. By the time the tomatoes start to get a little mushy, Lamar has less than. Read the problem. Okay, so I'm going to go back up here and choose the less than sign. And I'm going to go to my notes and make a note here that it's this symbol because of less than. Okay? Okay, select the common exponential base. It's 2. It actually is 2. Remember, if you want to see some information on that, 1 over 2 is the same thing as 2 to the negative 1 power. That negative exponent flips it. So if we can do that with 1 over 2, and oh, by the way, there's an x here. So this is 1 over 2 to the x power. I took the fraction that's inside the parentheses, and that's what I wrote with the negative exponent. I'm going to go one more step and remind you that a power of a power requires you to multiply the exponents. 2 to the negative x, which is what I'm going to type there. I guess if you think about it, 64 is a 6th power of 2. 2 to the first, 2 squared, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth is 64. So if you have 2 to the sixth is 64, when you make those into fractions, you're really saying then that this is 1 over 2 to the sixth. Well, okay, flip them back. So, in other words, how do you flip this 2 back around to the other side of the fraction? It must be a 2 with a negative exponent. You can check that. Hey Siri, what is 2 to the 6th power?
2 raised to the negative 6th power is 1 stroke 64, which is equal to 0.015.
There we go. So the key thing out of this learning is negative 6 is what I will put there for the other side of the expression. To rewrite with just the exponents, I'm going to say negative x, and I'm going to say negative 6. Because if they have the same base, you can cross off everything else. To write a simplified inequality or expression, I'm going to go to the paperwork for that one, so take a look. The fact is negative x is less than negative 6. Well, if you're going to solve for x, we have to divide by negative 1. And taught or not taught this year, we need to recognize dividing by a negative 1 is going to change the symbol less than to open it up the other way. This means we have x is greater than positive 6. X is greater than 6. Okay. It has been at least 6 days. Didn't like the 6. Didn't like the at least. It liked the 6. It has been more than 6 days. Check. Hey, thank you for watching this video. These are tough. You might need to use multiple hints to work your way through the problems. Stick with it. Thanks for watching 8 minutes of a math video. You're awesome. And I hope to be able to help you out with some other math problems along the way. Thanks for sticking around. Talk to you later. Bye.